Hi everyone, my name is Jake and I want to show you a hardware wallet implementation for Burstcoin using the Ledger Nano S. But first I just wanted to talk a little bit about key generation for Burstcoin. If you're not interested or you already know this, you may want to jump to the demonstration of the Ledger Nano S wallet. When you create an account using the current online wallet, it provides you a passphrase, a very long passphrase. In this example, I'm using a very short passphrase, which no one should use. Um, but after the passphrase is generated and re-entered, the passphrase is run through SHA 256 and then run through a second process called clamping, wherein a few bits are flipped in the first and last bytes. From this, a curve 25519 algorithm generates both a public key and a signing key. The public key here in green indicating that it is eventually broadcast to the Burstcoin network and public information. From a public key perspective, how do we get to the address? Well, another SHA 256 operation, and then the first 8 bytes are reversed from endianness and converted to decimals. So you might recognize this type of number as an account number on the Burstcoin network. Then an algorithm known as Reed-Solomon is applied to generate kind of the canonical address format. You'll note that the address does not contain all of the information in the public key. This is why it's important that you do a single transaction but with a new address before you use it. This secures the address using the full public key. In theory, there could be many public keys that are hashed to the same address, and so by broadcasting your public key, the network then secures the address to that existing public key. Let's talk a little bit about the Ledger Nano S. Like many hardware wallets, it's designed to keep your seed phrase secure such that it never leaves the device. During generation, the seed phrase is displayed to the user on the display for the purposes of writing it down and backing it up, but after that point, the seed phrase is completely secure in a secure element similar to the secure elements that secure other financial transactions. The Ledger SDK provides a function known as OS Perso Derive Node BIP32. This function will provide 32 random bytes of key data, given a key path in BIP32 format. You'll note here that 30 actually indicates Burstcoin. You cannot reverse engineer the 32 random bytes of key data back to the master seed, and depending on your key path, there is additional salting going on, so in theory, your master seed phrase is kept perfectly secure. Once you have your key data, a process called clamping flips a few bits in the first and last bytes to provide the actual key phrase, which is then passed to a curve 25519 algorithm to generate both your public and your signing keys. One note in the architecture of the Ledger Nano S SDK is that the OS Perso derived node BIP32 uses entitlements to prevent apps from generating keys that are not within their key space. Also, when generating key data, this function likes to know what algorithm you're using for cryptography. The way the entitlements work on this function, it does not allow me to pass a curve 25519 algorithm and get back key data. I'm instead using the ED25519 curve for the purposes of generating key data, which I think is very similar in that you're basically getting a random 32 bytes derived from your master seed, and I think that this is okay, but I'm not a cryptographer and it might be a bad idea, and this is only a proof of concept anyway. Just some notes on how the transactions work with the online wallet. When you go to send money on the online wallet, it will send the parameters to the server that's running your online wallet. So you'll send the address, the amount, the fee, any messages, things like that. And the server will send back an unsigned transaction. Then the online wallet will require you to enter your passphrase to do this transaction, and it will actually sign the transaction completely locally, I'm pretty sure. You know, you can always have malicious wallets that might want to capture that passphrase. So, but in an ideal situation, the browser on your host machine is where the cryptography is happening, and a signed transaction is sent back to the wallet server for broadcast to the network. You can also have malicious software running on your computer, such as malware, that could be harvesting passphrases. So this paradigm isn't perfectly secure. Conversely, when using a hardware wallet, the hardware wallet is designed to keep the private keys completely secure and never leave the device. In my implementation, the desktop app generates the transaction itself rather than using the online wallet server to generate the actual transaction bytes. This transaction is sent to the Ledger Nano S for signing. The user is required to indicate on the device by pressing a button that they allow the transaction to proceed, at which point the signed transaction is sent back to the host machine. Then that signed transaction can be broadcast to the network. Let's do a quick demo. For purposes of this demonstration, we're going to use a Python script as the desktop application. In reality, you might use Google Chrome's U2F API to communicate directly with the Ledger Nano S and provide signing transactions directly in the browser. Our demo app has two features. One, request the public key, and two, send money. Remember, I don't know the passphrase of this application, so I can't even log into the current Burstcoin wallet since I don't know the passphrase. It's derived from the seed phrase that was created when the Ledger Nano S was originally configured. First, we should unlock the Ledger and select the Burstcoin app. Since it's not an authorized app from Ledger, you have to authorize the app to run. Now, running the application, you get your public key and your address. I've already sent a few bursts to this address so that we can demonstrate sending and signing transactions. First, enter an address to send money to. Second, the number of bursts you wish to send. A transaction is created, and you'll notice that the ledger is now showing information about that transaction, including the full amount, the address that you send to, and the fees involved with the transaction. The user needs to explicitly authorize the signing action before the private key is used to sign the transaction. You'll note here that we got a transaction hash back, and the transaction was sent to the blockchain. If you look in the wallet here, in the receiving address, you'll note here the transaction was just recently logged. And that's it. I intend to eventually clean up the source code and post it to GitHub, but since it's just a proof of concept, and I'm not a cryptographer, I'm not sure if I would recommend it for use for actual cryptocurrency, but I hope you enjoyed this video. Thanks.